Good morning, good afternoon, everyone. My name is Chai Kim Chan, the Director of CTI Resources in Sdn Bhd. Today, I would like to share with you some of our experience about AI-driven solutions in water management. It is no surprise that digital transformation in water operation is on the rise. Several digital water technologies such as IoT, smart sensors, big data analytics, machine learning, and artificial intelligence are used in the digital transformation journey. When surveyed, 23% of the water authority are considered AI implementation a top priority. What is AI or artificial intelligence? Artificial intelligence is a technique which enables machine to mimic human behaviors using data, logic, if-then rules, and decision trees. AI has two subsets. One is machine learning, which is a subset of AI techniques which uses statistical method to enable machine to improve with experience. Deep learning is a subset of machine learning composed of algorithms that permit software to train itself to perform tasks like speech and image recognitions by exposing multi-layer neural network to vast amount of data. Hence, artificial intelligence is a data-driven, model-driven, and process-driven. We require all three in order to work for a long-term success. The roles of the AI in the water supply system, which means that in the context of delivering efficient water supply, AI is mainly applied to decision-making tasks on how water utilities can maximize information and data available to make better decisions while enhancing service delivery. AI is also used to optimize capital investment and also to reduce operating costs, including social and also environmental externality. How AI helps in water supply system. Look at the water supply network. AI will be able to help to optimize water resources, optimizing water treatment plant productions and process, optimizing water distribution network, and also optimizing the wastewater treatment process. Hence, it's actually based on the artificial intelligence of the data and model at the processes. It will provide an effective water treatment processes that optimize chemical usage, filter efficiency, asset performance, and energy management when it comes to a water treatment plant process. When we look at the water network or distribution network, the demand forecasting and network leakage detections is based on AI technology, which enable the water operator to provide a smooth delivery of water supply to the consumer. So these are the applications and areas that AI helps in water supply system. However, there are fears and challenges when we implementing AI. The first is data. My data is bad. My data is in manual format and we do not have enough IoT sensors. Very often, these are the message or the command that we hear from our customers. The second complaint or the fears is cost. We require a high initial capital investment, and we also require expensive IT infrastructure to run complex AI applications. Furthermore, the license cost of these AI applications is very high too. The third one is speed. Very often, very long implementation time for AI project, partly because of the change management, whereby we require to get the operator to work with AI process. And this time constraint has become a problem and a fears. The third one is actually, we require to use cloud computing in most of the AI computer or the applications. Hence, it only works with high-speed internet and we do not have any connections. So this is enough fears. The fourth one will be design and support, whereby we require subject expert, matter expert, as to work with the data scientist. Then we also require an expert for an ongoing maintenance of this AI application itself. So these are generally the fears and challenges of the AI when we implementing. Our partner, Coyotes Datalytic from Australia, understand the fears and the challenges that are faced by our customer. Based on their experience in water operations, they have designed and developed applications using artificial intelligence to help water operators to better manage the water supply system. Who is Coyotes? Coyotes is an Australian-based company. In fact, it is part of one of the well-known water authority in Australia. He has various expertise such as engineers, IT, SCADA professions, data scientists, hydraulic modeling, and also the process engineer. So the applications that designed and made by Coyotes is made by operator and for operators. What strategies actually Coyotes is using in order to deliver these solutions? We are delivering and we are employing the edge to cloud strategies. We have an edge device located at on-premise to act as a data collector to connect and integrate in most of the application or the system on the field. These are such as SCADA system, historian system, IoT sensors. These are the automatic data. We also can collect the manual data such as the lab test result, manual operation data, also some asset data. So this manual data and also the automatic data will be digitized and integrated by the edge device with the collector. We are also able to integrate with the external database such as weather conditions. These weather conditions will be used as the parameter for the demand management and also the water resource optimizers to work. This data will be collecting and then pumped into the cloud computers. We are using Microsoft Azure to run the sophisticated AI applications. So these applications will able to deliver and make the system have a total data integrity and validation. We have about 6 applications so far that deliver and designed by the Coyotes Datalytics. They are namely chemical dosing, stock management, compliance management, filter performance, demand management, and aeration management. Let us look at few of the applications that provided by Coyotes. The first one is a chemical dose optimizer. Very often in a treatment plant, the chemical dosing rate has been run in the fixed rate, and it also, the changes of the fixed rate is depending on the lab test result. While the late or the delay in the laboratory test result, very often that actually make the dosing rate unusable. Hence, we require an advice or automatic or advice from the chemical dose optimizer to provide the recommended ideal chemical dose rate in real time. These ideal recommendations will require to provide balance between the risk, downstream processes, and chemical cost saving. These applications also require to adaptively smoothing to adjust the learning parameter automatically. The chemical dose optimizers that from Coyotes enable us to perform a digital gel test in real time with clear recommendation for actions or set point for the process. Let us look at one of the customer example. This customer is in South Australia, is located in Riverland region. This customer has a series of 10 water treatment plants located in the Murray River in South Australia, supplying water to towns and communities along the river. These 10 water treatment plants has a various sizes ranging from 4 mld up to 90 mld. All the 10 water treatment plants is taking from water from the same Murray River. However, the water quality of this Murray River is generally cloudy or turbid, carrying impurities in the form of very fine suspended clay particles. along with the organic matters. Because of the rapid change in the raw water quality, the lab test result, which of the manual form, is not able to provide a good dosing rate and hence affect the efficiency of the water productions. If they maintain as a high dosing rate, hence it increase the cost of the chemical usage. Therefore, they apply this chemical dosing optimizer in their 10 treatment plant. They started in one treatment plant, and then within 6 weeks to 8 weeks, the result has shown some significant improvement. Let us see the result. This result has been taken from one of the plant for alum dose. You can see that there is two parameters where it's called current dose rate. The other one is the predicted dose rate. The current is set at 43, but the predictor says that you can set it for 40.1. This is because based on the raw water conditions and also the downstream process analysis, the predictor says that we can run as a lower dosing rate. If we adjust the dosing rate lower than the current set point, we have significant saving of 17.8%. Let us look at the middle graph. It shows that the dotted line, the green is actually the actual dosing rate, and the orange is showing that the predicted advised recommended dosing rate. The dotted line shows that operator didn't follow the predicted rate or advised or recommended rate, and hence there is a waste of chemical usage. The moment that they turn on the chemical dose optimizer or the follow the recommendations, they say you can see that the dosing rate and also the predicted between the actual and predicted are run concurrently. So they will significantly save the chemical usage and improve the treated water efficiency as well. From the result, when they apply this chemical dose, this customer Riverland in Australia and able to save more than 6% of the reduction in chemical consumption. Reduction is operator workload and management of a plant based on the river monitoring. Hence, customer is happy with the chemical dose optimizer. Let us look at another application called filter management or filter optimizer. Filtrations happen into require a backwash. And the backwash operations is based on two parameters. One is loss of head and the other one is a time. Very often, these two parameters is used based on plant design and initial commission data. But over the years, when we run the filter, the performance has deteriorated and we require adjust accordingly. Each of every filter has a different adjustment. However, water operator required to know, they require some guideline and the predictions enable them to run smoothly. Very often also, the water operator require a schedule the filter backwash operation. Hence, with Filter Plus Optimizer, it provides a smart predictive AI back filter management that delivering real-time results, including predict and analyze filter efficiency based on solid loading rates. We can forecast backwash times and optimize backwash scheduling, increase filter runs hour whilst maintaining or improving filter bay health. Let's look at one of the example. This example is in Zhejiang province in China. This is a wastewater treatment plant where they have 6 cents filter. The production is actually about 120 mld wastewater treatment. However, the problem that they are facing or the challenge that this customer is facing, they have an underperformance of the classifier and also the bad filtrations. Then they apply this Filter Plus Optimizer, and the result, they will be able to gain significant sustained energy reduction in coagulant chemical consumption, improve filter operation, and also increase hydraulic capacity. Let us see the result. This is one of the performance and the recommendations that done by this Filter Plus. Besides providing the predicted and also the backwash duration, this chart shows that Each of every filter, for example, filter A, when we want to run this filter, you require to run 2 pumps, and the time that you require to run is 180 minutes. When you have filter B, the next backward cycle, you only require to run 1 pump, and the time is 150 minutes. So with this recommendation, you can see that each of every filter require different type of operations set point. With this set point, it has significantly saved the energy usage because we can run a lower number of pumps, and also reduce in terms of the time taken and also the water that been used. That is a significant saving. The third components that we like to introduce is called demand management or demand optimizer. In the distribution network, the demand is keep changing because of a different requirement. For example, in the residential area, before COVID happened, everybody is out to work, and the residential area will use the water, less water during the daytime. But during the COVID period, the usage of the water in residential area has increased because everybody start to work from home. So this environment or this situation change has actually impact the demand and also the treatment plant productions. Therefore, a real-time AI forecasting and simulations of water demand for plants and network of this demand optimizer will provide a demand forecast and require supply rates up to 14 days out. It can also abnormally detections and alerting of the network behavior, such as the burst or unusual usage pattern from reservoir zone, DMZ, or plant. The model future state storage volumes and recommend production targets to maintain storage objective of water network resilience. It also provides assessment of impact based on changes in the network of key demand factors such as maintenance, weather, transient population, and industry. It provides optimized set point for water productions and distribution, maximize energy efficiency and carbon emission. Let us look at one of the example. This customer is a city with a 200K population in North Queensland, Australia. They are deploying and provide a real-time demand forecast with existing sensors and infrastructure for the city in under 1 week for emergency. So the result and the benefit is to reduce energy consumption, identify network event, optimize maintenance, planning and scheduling, and enable what-if planning during major network incident. So let's look at one of the chart and provided by the demand manager. This chart is showing that the recommended rate is 136 liters per second. So from the chart, the 0 means that the current value, or the value that is seen from a chart is predicted. So if there is any cut of water outage, the orange color shows that with the reserve from the reservoir, with the demand pattern that currently been detected and analyzed, it will only have 20 hours before it run dry. So this is one pattern and one forecast. What if we maintain on the current set point, current pumping rate, and based on the demand pattern that we have, the green color will show that is the predictions for the next 7 hours. However, you can see based on the predictions, there is a sharp drop and not enough water supply to that areas because we do not change any of the pumping rate or the operation conditions. So the recommendation value says that based on the demand pattern, demand analysis or the AI, if you increase the pumping rate to 136 liters per second, you can see that there is a blue color dotted line. We are unable to maintain the demand supply to the resident area. So this is the projections that given by the demand manager itself. So from here, operator or water supply can actually, based on these to maintain the sustainability delivery services to the customer. In summary, AI is actually significantly improve the water supply quality, whereby the solutions that provide by the Coyotes Datalytic enable us to provide this proven result, such as ongoing reduction in chemical consumption, reductions in membrane fouling and replacement. We can also predict asset performance by improving maintenance and operational pattern whilst reducing costs, and also in reductions in energy consumption for both the plant and the network. Hence, there are also others benefit and the result being shown in using AI in the water management. In summary, AI is the next era and is a necessary requirement for us to improve our services. Why digital water? Now, next, and beyond. We will need to use the latest digital technology to solve the now, reshape the next, and reimagine the beyond. Thank you for your attention.